My name is Josh Qualls. I am the Loudstorm account manager here at 6 Feet Up. And today I'm joined by Paolo. He's going to be talking about maps in Django. I'm super excited about that. He was telling me a little bit about some of the things in his presentation, and I'm super excited to hear more about that.
Hello, everyone. I'm very happy to be here with you all, even if it's remotely. In this talk, we'll see together how to build various types of maps using Django from scratch. If you're asking yourself what type of map we can build with Django, let's see an example together right away. These maps show mountains, peaks, and spot elevation location. We all use maps like this every day in web or mobile application. I built this map with Django using the free Natural Earth geographic map dataset. In this talk, we'll see together how to build a map like that, but first I'll present a bit myself. I'm Paolo Melchiorre, and I'm the CTO of 20tab, a Pythonic software company based in Rome, for which I work remotely. I'm a software engineer and long-time Python backend developer. After using Django for a few years, I became a contributor to the project. I also really like hiking in the mountains, so I decided to build a map where I can put all the points I've reached. I took this photo from the starting point on my last hike. I was on the Italian Apennines and the sun has not yet risen. But trust me, in the distance there is the Adriatic Sea. The making of this map will be a bit like this hike. We'll start from an easy stretch with little slope, and then we'll go up in altitude, where things will get more challenging. But let's start from the basics about web maps. A web map has many features. It can be static or dynamic. You can interact with it, or you can only view it. The map can use raster or vector tiles to represent the surface. Usually, the data is stored in a spatial database, and a web map will use a JavaScript library to show data on your web page. On Wikipedia, regarding web maps, we can read that web map is the process of using the maps delivered by geographic information system on the internet. But implementing a geographic information system from scratch is beyond the scope of this talk. To do this instead, as you can imagine, we are going to use Django, my preferred web framework. The requirements to create our map with Django are a stable and supported version of Python and the latest stable version of Django itself. In my example, I installed it in a virtual environment. To create the mymap project, I switched to my project directory and then use the start project Django command. The basic file of our project will be created, as you can see here. After switching to the mymap directory, we create our markers app with the Django startup command. Again, all the necessary file will be created for us. Now we have to activate our marker application by inserting its name in the list of the installed apps, here in the settings of our project. At this point, we can proceed to insert in the markers view file a new template for the page of our map. In the markers template directory, we can now create a template file for our map. For now, we add only usually boilerplate with a title, but without a body content. In the markers URL file, we must now add the path to view our map using its template view. As a last step, we can include in turn the URL file of the marker app in that of the project. We just made a first view in Django, but it will show a blank page. so we can avoid checking the browser content, and let's move on to something more challenging. I took this photo after an hour of walking in the dark. You can see the sunrise in the distance. We are about to start the high altitude path. As for our hike, something will begin to be seen in our project as well. In fact, we'll add a blank map to our page using the Leaflet library. Leaflet is one of the most used JavaScript libraries for web maps. It's a free software and it is a desktop and mobile friendly. Leaflet is very light. It weighs less than 40 kilobytes. It has a very good documentation that you can read online. To use Leaflet, we need to link its JavaScript and CSS module in our template. We need also a div tag with map as ID. In addition, using the static template tag, we'll also link our custom JavaScript and CSS file, which we'll now create. We add our CSS file in the static directory, and inside it, we add only the basic rules to show a full screen map. In our JavaScript file, we add the code to view our map. Using the defined variables, we initialize an OpenStreetMap layer. We hook the newly defined layer to our map. The latest statement sets a map view that mostly contains the whole world with the maximum zoom level possible. We can now start our Django project with the run server command, and we can finally visit our map page. We just created an empty map with Django, and the result is pretty much what you see now. A map without markers, showing the whole world. This photo shows the crossroad at the end of the first part of my hike, just before a very challenging uphill stretch. The sun has risen for a while and the landscape is clearly visible around. Likewise, after having clearly visualized our map, we will now start a bit more elaborate part, writing more code to create our markers and display them. It's time to get to know and activate GeoDjango, the Django geographic module. Django added geographic functionality a few years ago in the contrib.gis module, with specific field, multiple database backends, special queries, and also admin integration. Since then, many new useful features have been added every year until the latest version. Before activating it, we need to install some requirements. Mandatory GeoDjango requirements is GDAL. It's a OSGeo library for reading and writing raster and vector geospatial data formats. It's released with a free software license, and it's a variety of useful command line for data translation and processing. To easily install the GDAL package on a Debian-based system, you can use the apt package manager. For other operating systems, you can read specific instructions in the Django documentation. We can now activate GeoDjango by adding the contrib.js module to the installed apps. Here in our setting. To use GeoDjango correctly, we need to change our database engine and use one of the compatible database backends. In this case, we have chosen to use Spatialite. Spatialite is a special extension to SQLite, the Django default database backend. It provides vector geodatabase functionality, and it's released with a free software license. It has a simple architecture. A complete database is an ordinary file. As before, on a Debian-based system, we can install the Spatialite package using the apt package manager. Let's add Spatialite as a database backend, setting the default engine in our project setting. We can now define our marker model to store a location and a name. Our two fields are both mandatory. The location is a simple point field, and we'll use the name to represent the model. To easily insert new markers in the map, we use the Django admin interface. We define a marker admin class by inheriting the GeoDjango admin class, which uses the OpenStreetMap layer in its widget. We can now generate a new database migration and then apply it to our database. We also create a new superuser to access the admin interface after starting the project locally. We can now start our project with the run server command, and we can visit our admin section. Here is the page for inserting the markers in our admin. As you can see, we have a text field to enter the name and a widget that we can use to manually navigate the map, and then manually define our point in the space. After having created more markers, we can finally show them in our map. We can do that by adding the information in our view. Here, we are retrieving all the markers from the database and converting them to GeoJSON before adding them to the context of our view. In our template, we use the JSON script template tag to securely add our marker to our page. The JSON script template tag will generate a code like this. As you can see, there is the GeoJSON inside the script tag. Let's edit our JavaScript file and store the GeoJSON in a variable. Starting from this variable, we build a layer for our map, and we extract also the name of the single marker. Finally, we add the layer in our map by setting the view to contain all the data. We can now start our project with the usual run server command and finally see our marker in our map. In this map, we see the few markers I uploaded through the admin. They are inside the page code, but the loading is this fluid and fast. You can also see the pop-up on the marker of the peak I'm heading toward in this hike. But if you add a lot of more markers to show, our map loading will be much slower and Leaflet will have a harder time rendering it. We need a more complex solution here. This photo shows a beautiful landscape that came to my site at the end of a challenging climb. The highest peak begins to be seen, but there are still challenging passages before reaching the summit. We then continue in implementing the final version of our map. First, let's start using PostGIS as a new backend engine. PostGIS is a PostgreSQL extension, and it's also the best database backend for GeoDjango. It internally integrates spatial data and has a spatial data types, indexes, and function. In order to use PostGIS as a database backend, we need to install the PostgreSQL C client library. As before, you can do it easily with the apt package manager. We modified the project database setting, adding the PostGIS engine and the connection parameters of our PostgreSQL database, which you may have locally or remotely. The Python requirements of our project are increasing, and therefore a good practice is to create a requirements file with the package list. We'll use the Python Postgres database adapter, Django REST framework, its geographic add-on, and also Django filter. We install all the Python requirements using the Python package installer module. The packages that we'll use directly in the code of our project are Django REST framework and its geographic add-on, which we then insert in the list of the installed apps in our setting. Let's create a serializer for our marker class. Inheriting from REST framework GIS serializer, we only have to define the marker model, the geographical field location, and also the optional fields to be shown as additional properties. In this case, ID and name. Our intention is to expose our markers via a RESTful API, and to do so, we define a read-only viewset. We set the location as a field to filter our markers, and then a filter based on a boundbox. We also return all our markers instances without limitation or filters. In the markers application, we define the URL of our new endpoint using the Django REST framework default router to create our path. Finally, we add to the definition of our URL of our project a new path for the API that includes the path just specified for our marker app. After finishing our RESTful API, we move on to update our JavaScript. As we no longer have the data preloaded on our page, we no longer have a way to position the map so that it contains all the markers. We try to locate then the user. In the positive case, we'll use its location to center the map. And in the negative case, we'll locate him on an arbitrary point in the map with a low-level zoom. By no longer loading the marker directly on the page, we therefore ask our endpoint to return only the markers of the specified displayed area, passed as bounding box string. To build the marker layer, we ask our endpoint for data asynchronously and extract the properties we want to show in the pop-ups. We then invoke this flow every time the user stops moving the map. This JavaScript code is only to show how to use our Django GIS, and is not a final version you can use in production, but it works. And finally, here is our complete map. In this example, we can see how the marker in a specific map area look. The loading takes place in a very fluid way because the number of calls occurs only when the movement on the map stops. And therefore, the data traffic is reduced to the essential, as well as the rendering of the markers carried out by leaflet. The hike has also reached its final destination. Unfortunately, the view is a bit covered, but we can finally add a new marker on the map. It was one of the longest hikes I ever made, and I hope to be able to do new ones soon. There are also many other features that can be added in the future. For example, markers customization and pop-ups to show more information on it. Marker filtering based on relational data. The clustering of the markers both in the front end to improve the visualization and back end to make the loading of data more efficient. The use of geocoding services to add marker locations starting from the address, and so on. And at the end of this talk, before saying goodbye, I want to share with you some tips. They are based on my experience as a map developer with Django. First of all, read the documentation in the Django website. It's full of information about GeoDjango and its evolution. Read also details about geographical queries in the PostGIS website. It helps you to understand how things work at a lower level. Read also the source code of both the project in GitHub, because there is something you can learn only from the source code. Search for questions on Stack Exchange, but try to answer them by yourself and not only reading the answer. Last but not least, you can also study this presentation because it is released with a Creative Commons license. In 20 tab, we have developed many maps with Django. You can find more about our open source project and our Pythonic works using these contacts here. To find out more about also my personal work with Python and Django, use all my contacts. Using this QR code, you can download this presentation on my website. It will be released in a few minutes. Thanks again for having me, and enjoy the next talk in the conference.